case you didn't grasp this from the intro, when you have three congruent angles, these angles will always form similar triangles. Angles are an important part of triangle similarity because if you can prove that a triangle has the same angles as another, then you can in turn prove that the two triangles are similar, meaning they are the same shape, just a different size. By the end of this video, you should be able to determine whether triangles are similar and write a similarity statement for similar triangles. Here's our standard of proof for triangle similarity. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. Oftentimes in math, we show triangle angles being congruent with these little whoop-de-whoop symbols. That is the technical term for it. So matching whoop-de-whoops mean congruent angles. This shows that A is congruent to A prime, and that B is congruent to B prime. Because we've shown that A is congruent to A prime and that B is congruent to B prime, we've satisfied our proof right here where two angles from each triangle have to be congruent. So these two triangles are similar. But we just talked about the fact that similar triangles have three congruent angles, that all of the angles are the same for similar triangles. So if we know that two are congruent, why do we not have to prove that the third one is congruent as well? Well, this comes back to the fact that all triangles add up to be 180 degrees. So if I knew, for example, that A was 50 degrees and that A prime was congruent, and that B was 60 degrees and that B prime was congruent, I know based off of the fact that this triangle has to add up to be 180 degrees that C prime has to be 70 degrees. And so by proving that two sets of the angles are congruent, we're really proving that the third one has to be congruent as well, because both of the triangles will add up to 180 degrees. Similarity statements are just a shorthand way of writing what triangle is similar to what. I have two sets of similar triangles right here. We're going to start with triangle ABC, and I'm going to write a similarity statement for triangle ABC. If I want to write that triangle ABC is similar to something, then I'm going to use the similar symbol, which is just kind of like a wavy thing. Now I want to say that triangle A is similar to another triangle, but I need to make sure that the second triangle lines up in the same order where the angle that is similar to A comes first. So in our picture here, angle A is congruent with angle X. So I'm going to start with X. Angle B is congruent with angle Y, so after X comes Y. Angle C is congruent with angle Z. So triangle ABC is similar to triangle XYZ. If I change this similarity statement to instead read triangle ACB, then that would have to be similar to triangle XZY. You have to make sure that the angles line up where the order that they show up in the first triangle is the same order that they show up in the next triangle. Let's just do this for this second group of triangles right here. If I have triangle QRS, then triangle QRS will be similar to whatever angle is congruent to Q. Q is my 59-degree angle. In my other triangle, L is my 59-degree angle. So if Q comes first, L has to come first. If R comes second, R is my 90-degree angle. So N is going to come second, with M being last. This example is asking us to either prove or disprove the similarity statement. Is triangle GHI similar to triangle JKL? Remember that in order for triangles to be similar, we just need two matching sets of angles, and I can already see a match right here. I is going to be congruent to L. So as long as I can show that one more set of angles matches, then I know that these are similar. Unfortunately, angle G and angle K, the only two other angles that are given to us, are not matching. So I can't tell just by looking at what's given to us that whether or not these are similar. I'm going to have to do some solving. Angle H shown right here is not given to us, but we can figure out what H is just by remembering our rules for interior angles of a triangle. They should all add up to be 180. So if I take off 33 and take off 26, I should end up with what angle H equals. Angle H equals 121. I've now got another match. So H is congruent to K. I've got two matching sets, which means that, yes, this is a true statement. The two triangles are similar. We're going to do that same thing with this right here, but it doesn't give us any angle measurements. Although I can see angle G and angle I are a match because they're both indicated as 90-degree angles. So I've got a match right here between angle I and angle G. I'm not able to solve for any more angles, but if you look right here, these angles share a special property. These two angles are vertical angles. They're angles that are across from each other in the V. We learned about these the very first day of this chapter. Vertical angles are also always congruent. So this means that these two angles right here are matching angles. So we have the matching set from angle I and angle J. We have the matching set from the two sets of H angles. We've got two matching sets of angles. These triangles are similar. Our final way of determining matching angle sets is by overlapping triangles. This picture is made of two triangles, triangle ABE and triangle ACD. As you can see, they share angle A. So even if these triangles were side by side, we could say that the top angle, angle A, was a matching set. Let's do a brief recap. We know three different ways right now to figure out if angles are matching sets. The first way is just by being given the angle measurements. So 34 degrees is equal to 34 degrees. That would be a matching set. The second way is by noticing vertical angles. If there are two vertical angles involved in the picture, then we know that those triangle angles are matching sets. The final way comes from overlapping angles. Let's use these to determine whether these following triangles are similar. Starting with triangle AZR, we want to determine if that triangle is similar to triangle AKL. Now immediately of the three options, I can see that I have a matching set using overlap. So angle A will be congruent to angle A. As long as I can prove that there is one more set of matching angles, then we can say that these triangles are similar. Angle R is 24 degrees, and angle L is also 24 degrees. So that is similar to our first example here, where it just gives us two angles being congruent. Angle R is congruent to angle L. Because we've proven that two matching sets exist, we know that these two triangles are similar. That statement is true. Next up, we have triangle ZGL, and we want to compare that to triangle KGR. So of our examples, just like last time, R and L are congruent. So we can say that R is congruent to L. We know that because they are both at 24 degrees. But I see one more set right here. Angle G and angle G. These two are vertical angles. As you can see, they form the V just like this. Vertical angles are congruent. So I can say, hey, angle G from the first one is congruent to angle G from the second triangle. We've got two matching sets, which means that our second example is also a true statement. Our final example, we're going to compare AKL to GKR. So the easy one, we know that L is congruent to R. Angle L is congruent to angle R. But after this point, things get a little bit tricky. I don't see any vertical angles here. There aren't any angles across like V's from each other, and neither of these triangles overlap. So at this point, we have nothing else to work with. So we can prove that one angle is congruent, but we can't prove that two angles are congruent. So this is not true. And that's really all that we have to cover today. You've learned how to determine whether triangles are similar, and you should know how to write similarity statements. The only thing that you don't know is how awesome today's haiku is. We come from all sides. Despite all our difference, we are similar.